going over the pretest practice and review for Chapter 6. I just call this the Chapter 6 review normally. What we're going to do is focus on the operation as usual. We kind of have a mixture of operations and a mixture of rules. This is a summary of exponential law. So we're going to say, okay, what's the operation? Addition. What's the operation? Multiplication. What's the operation? Exponent. Remember that this particular chapter dealt with a summary of the laws of exponents and a summary of the laws of distributive property. And distributive property is when you have a parenthesis situation. Now, let's summarize those. If you recall, we did that with the order of operations horseshoe, right? We said order of operations was parentheses and then exponents and then multiplication and division and then addition or subtraction. And we talked about way back on page 13, I believe, that addition done repetitively turns into multiplication, which done repetitively turns into an exponent. So those are the three main players, and that's their order of, I would say, power, the order of uh, magnitude, the order of how tough they are. Like addition's a little wimpier guy, and multiplication's a little bit of a tougher guy. He gets more done quicker. And exponent's like the big guy that can really get a lot done fast because 3 plus 3 plus 3 plus 3 turns into 4 times 3. So a string of additions turn into multiplication. And 4 times 4 times 4 times 4 times 4 turns into 4 to the 5th power. So a string of multiplying with like bases causes us to add the exponents. And so we went from addition up to multiplication up to exponents. So that's what we're talking about. Because of the way this was created and the way that that is arranged, then our laws of exponents just flow right back down the table. So we learned that if you put an exponent on an exponent, which is raising a power to a power, which is this example, then the rule is to multiply the exponents. When you put an exponent on an exponent, you multiply. In other words, x squared cubed would be x to the 2 times 3x to the 6th. And as we work our way down, then when you multiply with like bases, you add. So if we had x squared times x to the 3rd, we would get x to the 5th. And then as we work our way down, when you add, there's nothing down there, is there? So when you add, you do nothing to the exponents. Example, 2x squared plus 2x squared is 4x squared. When you add or subtract, the name stays the same, meaning you leave the exponent alone. And you couldn't even add them unless the name was the same. And so we learned how our laws of exponents flow down. And since multiplication and division are inverses, then when you divide like bases, you subtract the exponents. So those three little arrows are really all of our exponential law. And then we learned that distributive property also flows down the order of operations. And we know that distributive property is when something is in a parenthesis. And we learned that we can only distribute onto a one lesser operation. So this level exponent will distribute down to the next level, multiplication or division. So you can only distribute an exponent onto multiplication or division. And then that level, multiplication or division, will only distribute onto the next level down, addition or subtraction. And you obviously cannot distribute addition and subtraction because there's nothing down to distribute it on. Okay, so we built that menagerie starting from the first day of school all the way up through page 170, 171 in this textbook. Okay, so we're gonna go back and start on number one again by saying what's the operation, and we know that the operation is addition, and then we say what's the rule for that. Well, to add or subtract, the names have to be the same. In algebra, we call them like terms. On page 168, we said to be like terms, all of the variables and their exponents have to be identical. We have b's and r's, with the b being squared and the r being to the first. So the variables and their exponents are identical. So we say that those are like terms. So we're going to combine those. When you add or subtract, what happens to the name? When you add, what's your exponential law? What do you do, your exponents? Nothing. You do nothing to the exponents. The name stays the same. B square R, 6 of those plus 3 of those is 9 of those little b square r's. Any questions on that? Example 2 is multiplication. On page 5, we said to multiply. You multiply the numbers and you multiply the names and you get a new name. When you multiply, the names do not have to be the same. They do not have to be like terms, but they could be. The process, though, that we learned was to multiply the numbers. 6 times 3 is 18. And you multiply the names and you get a new name. And when you multiply with like bases, that means B's with B's and R's with R's. When you multiply with like bases, you add the exponents. So we'd get b to the 2 plus 2, b to the 4th. And then to our r's, when you multiply with like bases, you add the exponents. Those are understood ones. And so you'd get r squared. And so we get 18b squared, 18b to the 4th, r squared. Any questions on that? And so we're connecting on this one, pages 1 and 168. We're connecting on this one, page 5 and page 169 in the text. Number 3 is a distributive property, and we did distributive property problems like this on page 31, and then we revisited distributive property again on page 170. Here's how we approached that from the beginning, if you recall. We approached it all from an order of operations standpoint. We said when we're dealing with parentheses, we get to working with distributive, and you can only distribute one level down. So an exponent will distribute on a multiplication division. Multiplication division will distribute on addition subtraction. Addition subtraction will distribute on a nothing. And so the first thing we did is what we always do, and that is to identify the operations we're dealing with if there's more than one. And so we have the 5g crammed on a parenthesis. And so we have that multiplication because it's crammed on, and then we have a parenthesis. Now the order of operations says you do what's in the parenthesis first, so we check in there. We have subtraction. The rules for subtraction say to add or subtract, the names have to be the same. In algebra, we call them like terms. Page 168 says to be like terms, the variables and their exponents have to be identical. Those are not identical. The names are not the same, so we cannot subtract, meaning we cannot do what's in the parenthesis. The next operation we come to is multiplication. That operation, we're speaking of the operation, multiplication, is crammed on the parenthesis. And so we check for distributive when something is crammed on a parenthesis. Well, what will multiplication distribute onto? Well, it will distribute one level down. It will distribute onto either addition or subtraction. Is that what's in there? Yes. So we can distribute that 5g onto those two. Now we're really distributing the operation multiplication. So we're going to have this 5g multiplied to the first piece, 3g squared f, And then we're going to have the 5g again multiplied to the second piece. On the second piece, remember to carry the minus as a sign. We started learning that on sign rules on page 18. And so we're going to call that negative 2gn. Now, remember the way I teach, I don't try to bring that sign right there. I just wait. I take it as a sign of the number. When I figure out the answer to this, if that answer is positive, I'm going to put a plus back in between them. If that answer is negative, I'm going to put a minus back in between them. All right. So we're going to multiply the first two. Well, how do you do that? Well, page 5, we learned a little drill. You multiply the numbers. 5 times 3 is 15. And you multiply the names, and you get a new name. And when you multiply with like bases, g's with g's, you add the exponents. 1 plus 2 is 3, so we get g to the third. F has no partner over here, and so we just cram on the F. So there's the first part. On the second part, we multiply the numbers. 5 times negative 2. On page 18, we learned sign rules that said when you multiply or divide with different sign, the answer is negative. So we get a negative 10. To show that the 10 is negative, we separate our terms with a minus. Had that been a positive 10, we would have separated our terms with a plus. And now we multiply the names, and we get a new name. And when you multiply with like bases, you add the exponents, so you get g squared. There's an n here, but nothing there to go with it, and so we just cram on the n. The operation that separates those is subtraction. What we're dealing with is not like terms, therefore you cannot subtract. Therefore, that expression has been simplified. We simplified the expression using the distributive property. Any questions on number 3? Number 4. Again, as we begin a problem, we're going to say what operations are we dealing with. And we have that 3 crammed, raised to the parenthesis. The 3's crammed on the parenthesis, but it's crammed on there as an exponent. That was weird that I put multiplication, wasn't it? That's why I was stuttering. My words weren't making sense. Back up a little bit. We're looking for our operations. We have a parenthesis, and on that we have an exponent crammed on it. And so then inside we have a parenthesis. So on this one we have a parenthesis and an exponent. Now, the order of operations says to do what's in the parenthesis first. What's in the parenthesis? 3x y to the fourth, which is 3 times x times y to the fourth, is in its simplest form, so we can't do what's in the parenthesis. So that means we go to the next operation after parenthesis, which is exponent. We see if we can do it. Well, that exponent is crammed on a parenthesis, so we check for distributive property. We say, well, what will an exponent distribute onto? An exponent will distribute onto one level down, which is either multiplication or division. Well, you can see that we have in there multiplication, so that exponent of 3 is going to distribute onto the 3 items that are multiplied inside. Now, when we talk about distributing that exponent, then we're raising something to a power. And if you study page 171, when you raise to a power, we generally put the first power in parentheses. We're taking this power 3. You may say, well, it's not a power. Yes, it is. It's 3 understood to the first. We're going to take that 3 to the first power, and we're going to raise it to the third power. We're going to take that x that's understood to be to the first power, and we're going to raise it to the third power. We're going to take that y that is visibly to the fourth power, and we're also going to raise it to the third power. And so we distributed the exponents, realizing that what we're doing is raising powers to powers according to page 171. Now, when you raise an exponent to an exponent, raise a power to a power, the rule for exponents is that you multiply. Now I'm going to clean this up down here so we have room to continue. When you raise a power to a power, you multiply the exponents. That's what we're thinking in our mind. And so if we show our work, we're going to have 3 to the 1 times 3 is 3 to the third times x to the 1 times 3 is x to the third times y to the 4 times 3 is y to the 12th. 3 to the third means 3 times itself 3 times, which is equal to 27. So we'll have 27x to the third y to the 12th as a final answer. Any questions on number 4? So number 1, we looked at a basic addition with exponents involved. Number 2, we looked at a basic multiplication with exponents involved. Number 3, we distributed multiplication over subtraction with exponents involved. Number 4, we distributed an exponent over multiplication with exponential rules involved. Any questions so far? Now, number 5 also takes us back to page 5, where I actually showed you how to find the greatest common factor, but that's not how I taught you. I said we're going to reduce the numbers and reduce the names. And when you divide with like bases, you subtract the exponents. So we looked at number with number, then x with x, then y with y, and then z with z. This is how we handled it over page 5. And so in our work, we only looked at the numbers as far as the greatest common factor, and we said the greatest common factor between 28 and 42 is 7. 7 will go into 28, 4. 7 will go into 42, 6. And so that wasn't the biggest. The biggest would have been 14. So when you find those things, you could have just reduced again or just rethink it. We can divide by the greatest common factor, 14. We get a 2 and a 3. And then we do our x's. Remember that a fraction bar is division. And on page 5 and page 169, we learned that when you divide with like bases, you subtract the exponents. So what we have is x to the first over x to the third. I blew it up because it's so hard to see with all my writing in there. And here's how we did it. We just said, okay, what is the difference in the number of x's? And the reason we did that is because we were visualizing that there was one x on top and 3 on bottom, and that when you have a situation like that, you have some cancellation, and it was obvious that there was 2 left on bottom. So we would say, what's the difference in the number of x's? 2, 2 more where? Bottom. So we're going to put x squared on bottom. And then we looked at our y's, and we had y to the 5th over y to the 4th. Y to the 4th. And we said, okay, what's the difference in the number of y's? And we could see that the difference in the number of y's was 1. And we would visualize that that 1 extra y would be on top. And so we put that y on top. And then on the z's, we see that there's the same number of z's both places, so all the z's would be gone. And so our answer would be 2y over 3x squared. Any questions on that? Now, I do want to address one issue because there's something that you need to know that is a rule that you're supposed to really already know that we will review, and you're going to need this more as you journey through Algebra 2 and college algebra. If we were to look at it like this, you could say the 28 over 42, take care of that. And then the x to the first divided by x to the third, take care of that. And then the y to the 5th divided by y to the 4th, take care of that. And then the z to the 3rd divided by z to the 3rd, take care of that. Now I'm discussing this because there's some rules for exponents that sometimes my students don't remember. We would reduce this by dividing by that greatest common factor, 14, and we would get 2/3. So we go, okay, we're satisfied with that. That's 2/3. And then we're going to go to the next part, and people are going to show their work, and they're going to say, okay, when you divide with like bases, you subtract the exponents. We remember that rule. So we would have x to the 1 minus 3. Okay. Sign rules tell us that that would be x to the negative 2. And so what people will do sometimes and put x to the negative 2. But we do not allow a negative on an exponent. And we learned on page 13 a little thing in an oval in the middle of page 13 that says the negative reciprocates it. Remember that x to the negative 2 actually says the reciprocal of x squared. So it would be x squared reciprocated, which would turn into 1 over x squared. So if you tried to put that up there with a negative, that negative would command you to reciprocate it to the bottom. Okay? And so we just kind of said, okay, what's the difference in the x's? 2, where were there more bottoms? So that's where it's going to end up. Exponentially, that's why it ends up there. Let's look at the z's. Z cubed divided by z cubed. If we use exponential law, then we know that when you divide with like bases, I keep wanting to do that with the parentheses. When you divide with like bases, you subtract the exponent. So you get z to the 3 minus 3, which is z to the 0. Now, some people have it in their mind that that really ought to be a 0, but the answer is really 1. And let's talk about why. If you had z cubed over z cubed, you know that z represents some number. Let's just say for a minute that that z is the number 2. Then what we would have is 2 cubed 8 over 2 cubed 8. And what is 8 divided by 8? 1. There's another logical way to prove that any number to the 0 power is 1. You get the 0 power by dividing it by itself. So the 0 power really could be defined as z divided by z, or z to the 4th divided by z to the 4th, or z to the 5th divided by z to the 5th. Any number to the 0 power, then, is the result of something divided by itself, and anything divided by itself is 1, unless that something was 0, where division by 0 is undefined. Okay? Any questions on that? Got a little extra free stuff there. All right, number 6. Number 6 is an order of operations situation. We have a multiplication and we have an exponent. An order of operations says that you would do the exponent first. So we would do this first. So we're going to have 4 times something. Now, it's this little something right here that is worthy of our investigation. You may recall back on page 171, back up a page, you may recall back on page 170, example 5 and 6, we investigated that little situation. And we said that negative 3 squared is not negative 3 times itself. It is negative 1 understood times 3 squared. And we talked about that being the case because we said negative x squared. When there's a variable, then we realize there's an understood 1, and that understood 1 must be being multiplied. So we have to apply that same thing to a number. And so if we have negative 3 squared, we have to realize it's a negative 1 understood times 3 squared, just like that negative x was a negative 1 understood times x squared. And so we're going to rewrite this as what it really means to us, negative 1 times 3 squared, which shows us three operations: multiplication, multiplication, and exponent. And we know that we are to do the exponent first and get 9. So we have 4 times negative 1 times 9. It's all multiplication, which is commutative, according to page 28 or 9, commutative property. And so it really doesn't matter what order, but we normally do it left to right. And so we get negative 4 times 9, which is negative 36. Any questions on number 6? Okay. Well, I'm going to stop the video right there to kind of give you time to think about the laws of exponents and distributive summed up before we get into the word problems. And so then we'll just have 2 or 3 videos